the ground, it begins to decompose and release greenhouse gases into the atmosphere. But if you take that manure and cook it slowly in a gasifier, you get two things: hot gas and a charcoal called biochar. This biochar locks carbon away, keeping it out of the atmosphere for hundreds, maybe thousands of years.
Can we fire it up?
It's fired up.
All right, let's go. So this is the brain.
This is the brain.
Okay, starting up.
For Josh, burning manure means free heat.
Look at all this. This is not what you would normally find in a chicken farm.
Not normally, no. I'm a high-tech redneck.
Yeah.
But it's the biochar Josh is making that could help cool the planet.
All right, Josh, here it comes.
And it might just make Josh Fry a richer man in the process.
Stuff, huh? This is biochar. Black gold, the new black gold.
It turns out all that fixed carbon works as a super fertilizer, too. Josh is currently coming up with a business plan to sell his 4,000 kilo a day yield. Look for Fryochar soon at your local garden center or home improvement store.
You think maybe that could save the world?
It will help save the world, yes, in conjunction with other things.
Biochar shows a lot of promise, but it could take a long time to go global with this technology, and it would be costly. Josh's rig came with a price tag of about 750,000 euros, and we can't reduce emissions from power plants or cars with biochar. I still haven't found the silver bullet to fix the Earth. Next stop, San Francisco. There's an atmospheric scientist on the West Coast who has a completely mind-blowing new way to cool the planet.
Well, it's certainly good to deploy all this new technology, but it's not going to be enough.
Ken Caldera has been studying climate change for almost 25 years.
Somewhere in the world, a coal-fired power plant is being built at a rate of at least one a week.
So there's more to come.
He's got a pretty major news bulletin for me. It may be too late to save the planet by reducing CO2, but there is hope.
We don't have a better way of cooling the planet, but we do have a different way of cooling the planet, a way that's completely different from greenhouse gas emissions reduction, a way that can cool the planet very quickly.
Okay, so how is this different?
Let's imagine that this garden here is our world. The gases in the atmosphere create the greenhouse effect that we've all heard about.
Okay, that paints a picture.
The problem is that we've been putting more greenhouse gases in the atmosphere, and that's a little bit like closing the windows on the greenhouse and keeping that energy in, making the greenhouse hotter.
So what's the alternative?
If we think of a car parked in the sun, which is more or less the same thing as a greenhouse, one thing that we could do quickly is to put one of these shiny reflective things in the window, and that will reflect sunlight away from the car and cool the interior right away. And we can do the same thing with our planet.
So you're saying there's a way for us to reflect some of the sunlight before it even makes it into the greenhouse?
That's right, exactly.
Wow. Blocking the sun to keep the planet from heating up in the first place. This is a game changer. Create a massive array of mirrors in space. 16 trillion reflective disks about 1.5 million kilometers from Earth, working in tandem to shade the planet. But this is pushing the boundaries of what humans are even capable of. It makes putting a man on the moon look like a cakewalk. To haul an estimated 20 million tons of disks into space would require over 700,000 space shuttle flights, and the price tag would be mind-boggling. We're talking an obscene amount of money. Okay, I'm due back on planet Earth now. The Rocky Mountains, to be specific. I've landed in the old mining town of Gold Hill, Colorado.
Hello. Oh, hi. Hi, Sean Riley.
Physicist John Latham lives lives a semi-retired life in a cabin perched on the mountainside here. He doesn't think we need mirrors in space. We've already got them right here on Earth. They're called clouds. Decades of research have led him to a pretty stunning conclusion. We can engineer them to reflect more heat away from the planet.
Is this something that happens already with the clouds that we have?
Yes, all clouds reflect sunlight back into space, some much more than others.
Think about it. When a cloud passes over you on a warm, sunny day, ever notice a chill in the air? That's because water droplets in the cloud act like tiny mirrors, reflecting enormous amounts of solar energy back into space. Dr. Latham's idea: add more mirrors. It turns out, if you seed clouds with tiny particles of salt, they will attract more water and create denser, more reflective clouds.
Well, they are rather like the ones over...
We know we can make rain by seeding clouds. The challenge here is to create microscopic drops that will simply make the clouds denser and whiter, and to figure out how to spray billions upon billions of them into the sky. There's only one place on Earth where I might find a system like that. Next stop, Silicon Valley.